All right, ladies and gentlemen, welcome to our first live stream here, or recording, I guess, of our lessons for Algebra 1. Today we're going to talk about factoring quadratic polynomials in the form x squared plus bx plus c. One of the things that I want you to understand is this is kind of going backwards from what we've been doing. To this point, we've been taking things and multiplying them together to get these quadratics. What we're going to be doing today is we're going to be factoring them apart. The reason that we're going to do this is ultimately we're going to look to solve these quadratic equations when they're set equal to 0, and factoring is one of those methods. So in today's lesson, you can see here that you already know how to multiply. So if we take a look at this, quick review, we have 3x times x plus 2, and if you remember from what we've talked about previously, this is when we start to use distribution. 3x times x is 3x squared. And then we take a look at the second part here because we distribute to all parts evenly. We have 3x times 2, which is 6, and since it's positive, that gets the sign as well. So now if you take a look at the next example that we have here, learn how to factor, what we're doing here now is very similar to what we did with the monomial division. We're going to take a look at the binomial that we have here, and we're going to ask the question, what's the greatest common factor that we can take out of both parts? So instead of being given the monomial to divide by, we're going to have to figure it out. So since this is just a follow-up of the example above, we already know that the greatest common factor of this type of a problem is 3x. 3x goes into both parts evenly. So then what we do is we divide both parts by 3x. But now, instead of eliminating it, getting rid of it, what we're going to be doing with it is we're going to be taking it and we're going to be pulling that out front. So whatever we divide by is being pulled out front as one of our factors. So in this case, we'd have 3x out front. And what we have left with is where we were with our monomial division. 3x squared divided by 3x is x. And 6x divided by 3x is positive 2. So when we factor, we are pulling them apart. When we multiply, we're putting them together. So now another example along these same lines is what we see here. We already know how to multiply two binomials together. If you remember, we talked about that as being the FOIL method. So the main gist of our lesson for today is going to be, how are we going to factor x squared plus 5x plus 6 down into the binomial factors x plus 3 and x plus 2. So if we take a look at the first few examples that we have here, when we get these, I want you to think of them in terms of what I'm going to call a diamond problem, okay? Now, a diamond problem is when what you have is the same multiplying as it is adding. Meaning, when we take a look at this first example here of x squared plus 3x plus 2, I want to know what two numbers, when added together, are going to give us 3x, and those same two numbers, when multiplied together, are going to give us 2. So in this case, we're looking literally for the sum of 3 and product of 2. Okay? So the two numbers that we have that would fit the bill in this case are going to be 1 and 2, because 1 plus 2 is 3, and 1 times 2 is 2. So this part here matches what we see right there in front of that, and this part here matches what we see there. So what we do with those then, very simply, is we use them as the numbers, the constant parts of our binomial factors. So the variable is x. So in this case, we would have x plus 1 times x plus 2. Notice now that if we would FOIL these, we would get the same exact answer that we had to start with. If you take x times x, you get x squared. If you take x times 2, you get 2x. Then we go to 1. 1 times x is 1x, and 1 times 2 is 2. And if you combine those two middle terms of 1x and 2x, you add them together like we talked about earlier, you end up with 3x. So by pulling them apart now, what this will allow us to do down the road is it'll allow us to solve these types of problems when they're set equal to 0. Let's go through a few more examples here and take a look at how this would work. So here, in our next example, x squared minus 11x plus 18, we're going to start with those same two simple questions. Sum of negative 11. That was the first example. My apologies. And a product, in this case, of 18. So now when your middle term is negative and your last term, your constant term, is positive, that means we are going to be looking for two negative numbers that when we multiply them together are going to give us that positive 18. So with this one, what two numbers, if added together, give us negative 11 and multiplied together give us 18? The two numbers are going to be negative 2 and negative 9. In this case, if we multiply them together, negative 2 times negative 9 is 18, there's our constant, and negative 2 plus negative 9 is negative 11, there's our middle term. So with this example, what we'd have left is to write the factors. Now in this case, like we've done previously, the signs carry along with the terms themselves. So we have x minus 2 times x minus 9. All right. Okay. Now our next example, ladies and gentlemen, here gives us a positive middle term and a negative last term, constant, and a negative middle term and a negative constant. So with this one, what we have to look for is one of each, meaning our numbers, one of them will be positive, the other will be negative. Okay. So let's take a look at the first one. Since the middle term is positive, that means of those two numbers, the one that's going to be the bigger number is the positive number. So here with this one, again, we are looking for a sum of 3 and a product of negative 28. In this case, the two numbers that fit the bill for that would be positive 7 and negative 4. So once again, those two constants become the constants of our binomial factors. So that would leave us with x plus 7 times x minus 4. The other example that I have here for you, x squared minus 5x minus 6, is an example where now we are going to have a positive and a negative number, and in this case, the negative number is going to be the larger of the two. So here again, we're looking for the sum of that middle term, the sum of negative 5, and a product of negative 6. So in this case, the two numbers that fit the bill there are negative 6 and positive 1. So the factors for this example would be x minus 6 times x plus 1. So now I'd like to just take a minute to tell you that the order of these factors does not matter. If you would have written x plus 1 times x minus 6, that would be fine, because the commutative property of multiplication says we can move them around and not have any problem with the final product. As a matter of fact, if you switch them around and multiply them, you'd still come up with x squared minus 5x minus 6. Okay? Last examples that I have here for you are just some more practice. All right? So with these types of practice problems, like you're going to see on your assignment for practice, what you are looking for is the same every time. So more examples of the sum of the middle term giving us the product of the final term. Okay? So let's go through these together as well, starting with x squared minus 3x plus 2. So for this one, and I'm just going to abbreviate this as sum, or s, of negative 3 and p, or product, of positive 2. In this case, since the middle term is negative and the final term is positive, that means both of our terms are going to be negative. And again, the numbers that fit the bill here, negative 1 and negative 2, which again is an easy transition for us into our binomial factors of x minus 1 times x minus 2. Keep in mind that every time you're looking for that same pattern of how do I get these numbers to fit? How do they match? Okay? Next example to the right, x squared plus 6x minus 16. For this one, ladies and gentlemen, again, we're looking for a sum of 6 with a product of negative 16. Now for this one, ladies and gentlemen, since the middle term is positive and the final term, the constant, is negative, that means we're going to have one of each for our factors, and the positive one is going to be the larger of the two. In this case, the numbers that fit the bill here would be 8 and negative 2, which again transitions right into our product, or the product of our factors, x plus 8 times x minus 2. Okay? Again, just keep in mind that that pattern will not change for these basic trigonometric quadratics, not trigonometry, I'm sorry. So the last two examples here again are pretty straightforward. Since both the middle term and the constant are positive in x squared plus 4x plus 3, both of our numbers will also be positive. So again, as we take a look at a sum of 4 and a product of 3, the numbers, pretty basic here, are 1 and 3, leaving us with our binomial factors of x plus 1 times x plus 3. Okay? And the last example that we see here, ladies and gentlemen, is our x squared minus 9x minus 36. Again, since the middle term is negative and the last term is negative, that tells us that the signs are going to be different, and on top of that, the negative term is going to be the larger of the two, the larger of the values. So if we take a look at this, again, looking for the sum of negative 9 and looking for the product of negative 36, the two numbers that would fit the bill here would be negative 12 and positive 3, leaving us with x minus 12 times x plus 3. So again, ladies and gentlemen, it's just a few things to keep in mind as you go through these. The diamond pattern that we're looking for is the same two numbers that we have are going to have the same product as well as the same sum. Remember the patterns of, is the middle term positive or negative? And is the constant term positive or negative? If they're both positive, then both factors are positive. If the middle term is positive and the last term, the constant term, is negative, then you'll have one of each, one positive, one negative, but the positive one will be larger. If the middle term is negative and the constant term is negative, that simply means you'll have a positive and the negative one will be larger. And if you have a negative middle term and a positive constant term, then both of your terms, both of the values that you get will be negative. All right, ladies and gentlemen, hope this helps. If you do have any questions, we will be talking in class as we get to this lesson. Thank you, ladies and gentlemen, and Lord's blessings on your day.